statistics. We'll be revisiting a lot of this stuff later, but I feel like we've got a pretty good foundation going. So here we go. We are almost done with the basics of descriptive statistics. All that remains to explore are percentiles, and the 5-number summary. So let's look at our coffee data set that we've been looking at for the last lecture or two. And again, this is the amount in dollars that 10 MiraCosta College students spent on coffee during the spring 2018 finals week to the nearest dollar. Now, when we're dealing with location, what we need to do is we need to order the numbers. So remember that one good way to order was a stem and leaf plot. I'll go ahead and utilize that now. Oops. And we would start at 0, 1, 2, 3, and 4. Those would be our stems. We'll have one leaf here. We'll have 12, 15, 18, and 19 here. And then I think it's 21, 26, and 29, 33, and 42. Good so far? Awesome. So percentiles, which are denoted P1, P2, P3, all the way down to P99. Why only 99 and not 100? What do you think? If I have a line and I split it in half, I've made 2 intervals, right? So you always have one more interval than you have the number that you use to split them. So anyway, this will divide a set of data into 100 groups with around 1% of the data values, or 1% of the data values in each group. To find a percentile that corresponds to a particular data value X, simply divide the number of data values that fall below that particular X by the total number of data values, and then multiply the result by 100. Or if you know the percentile and you want to find out where that percentile is located within the ordered data, you simply divide the percentile K by 100 and then multiply by N. So in statistics ease, we have PK equals, whoops, got a little typo here. Please take note of this. If you have a later version of the notes, this may not be still in here. So the number of data values below X times 100, and then what else did we need? We needed this to be divided by N, and that would give us the unknown percentile. Alrighty. Or the location L is equal to K, which is the subscript of the P there, divided by 100 times N for an unknown location. Now, when we're finding an unknown location, if we get a decimal, just round up. There's other ways we could look at this, but go ahead, round up, even if the regular math rules would normally require you rounding down. Also, once you determine the location of a percentile, you need to go to your ordered data, very good, to find the good value, the data value. Cool, let's give it a whirl. So the 25th percentile, what we have is we have that our K is equal to, beautiful, 25. What was N? How many data values are there? Good. N is equal to 10. And then I think we will have what we need. So the general formula, remember, was L is equal to K divided by 100 times N. So L will equal to 25 divided by 100 times 10. And that came from these values here. Cool, cool. All right, and then we just crunch it out here. Do you see we would end up getting what? Good, 2.5. Now, we were told to round up, so we'll get 3. Is that the answer? No. Now we have to go over here, right? And we have to count from the minimum, 1. So 1, 2, 3. So the 15 is the one that is in the position where the 15 represents the 25th percentile. So P25 is equal to 15. Good so far? Awesome. All right, now let's find the percentile for the data value 18. So we've got a different situation here, right? We want PK. So K is the one that is unknown. So here, remember, we have to go to what? We have to count the number of data values that are below this 18 here, right? So there are 1, 2, 3 below, right? So the number of values below 18 equals 3. And then we go ahead and we find that K is equal to, good, 3 divided by what? Good, the total number of data values, N, right? So remember, N was 10, and then times 100. So K is equal to 30, right? So the percentile for the data value 18 is the 30th percentile. And that's still in dollars, right? All right, so this is how we matched them up. We had our N was 10. This time it was in the bottom from the one formula. And then we have our number of values below. 18 was 3. And we solved for K. And the general formula, was K equals number of values below X divided by N, and then times 100. Sorry, it got smushed in there. That was what we used. All right. And so this was the green, and here's our N. Groovy? All right, and that's our solution there. And now 75th percentile, we're back to the other method. So here again, L is equal to K over 100 times N. So L will be 75 over 100 times 10. This will divide out some of the 10, and L will be 7.5. Rounding up, we'll have L is equal to 8. So, counting, separate these a bit. Counting from the minimum, we have 1, 2, 3, 4, 5, 6, 7, 8. Good so far? And so therefore, the 75th percentile, P75, is equal to, good, 29. That's the one. All right. Now the median, we've done this before. Here we can do it the old-fashioned way where, remember, you count the values and then you average if it's in the middle. So you'd have, 1, 2, 3, 4, 5 from the bottom, 1, 2, 3, 4, 5 from the top, and then you could average them. Or you could think of it as, isn't P50 the same as the median? So you'll get a slightly different result depending on how you do it. If we do it using your regular median way, we would end up getting x tilde would equal to 19 plus 21, because these are both in the 5th spot, one counting from, they're both in the middle of the data set, divided by 2, and that's going to give us $20. And again, if you did it the other way, I think what would happen is you would, you might end up going up to the 21. But we'll just stick with this one right now. Okay. Hey, while we're at it, let's find the min and max data values. So the min, remember, was 0. The max was 42. There's 5 important numbers I see. One of them was just a practice problem, but maybe I had an evil plan. Maybe the 5 number summary consists of the following values. What do you think? The minimum value, the 25th percentile, which, by the way, is also known as the first quartile. And then they're special, right, because there's not as many quartiles. So we denote that Q1. The 50th percentile, also known as the median, or the second quartile, right? The 75th percentile, which is known as also known as the third quartile, denoted Q3, and the maximum. And these special numbers give you the values needed for a box plot. So it's often called a box and whisker diagram, and it's a graph of a data set that consists of a line extending from the minimum value to the maximum value, so that's the whisker part, and a box which ends are drawn at the first quartile and the third quartile, and then they also draw one at the median. Cool, cool. All right, well, why don't we draw one out? So here, what we have is, if we make ourselves a scale, and then typically your box plot is drawn up a little bit. So here we've got our minimum value, remember, is 0. Okay. And our maximum value was good, 42, which will fall about here, I think. Nope. And then you make a line. I'll redo my dots here. Make it prettiest as we can. All right. Good so far? So those are the whiskers, and then we had, if you recall, the 5-number summary was what? For this particular data set, we got 0 as the minimum. These are all in dollars. 15 was the first quartile. And then the median we got was 20. And then 29 was the second quartile, or the third quartile rather. And then the maximum is 42. So at 15, which is about here, maybe a little over. At 15 and at 29, we're going to set our outside of our box. Something like that. And then at the median, which was 20, you draw another line to show the measure of center. And so a lot of times we'll write in these values. So this was, 0, 15, 20, 29, and 42. Groovy? All right, so that's just another way to show, the spread of your data. And this spread, is related to the median, the location of the center of the data, all right, not the arithmetic mean. Now, in order to check for unusual values, what we do is we find the interquartile range. So, denoted IQR, it's going to be the difference between the first and third quartiles. A datum is considered an outlier if it is below the first quartile, Q1, by an amount greater than 1.5 times the interquartile range, or above that third quartile value by an amount greater than 1.5 times the interquartile range. So why don't we check and see if we have outliers? So what is the interquartile range? The Q3 minus Q1, and that is 29 minus 15, which is 14. So now we have to say, okay, well, 1.5 times the interquartile range is equal to 0.5 times 14, which is going to be, good, 21. So checking for outliers on the low end, we're going to say (15) minus 21. Well, that's going to be -6. And do you see that our minimum value is equal to 0, and that's greater than -6. So no outlier or outliers on the low end. And then on the other end, the third quartile value was 29, and we're going to add that value of 21 because we want to see if on the higher end, if we have an outlier. That is 50. Well, our max value was 42, which is less than 50, so no outliers on the high end. So we're done there. We don't need to do a modified box plot, but if we had found any outliers, you can use a modified box plot to represent outliers as special points, often using asterisks or points. Everything else is the same as the regular box plot. So you would so for a note on that, the original line, right, stays the same. Outliers are not part of the line or included in the line or whiskers. Okay, so I hope you have a wonderful day, and I'll talk to you soon. Bye.